Manufactured wood is everywhere. Each year, we make millions of cubic meters of particle board that goes into everything from the chairs we sit on to the houses we live in. But there's a problem. Most manufactured wood contains urea formaldehyde, a binding agent that sounds nasty because, well, it is. The federal government has classified it as a known human carcinogen.
In order to maintain our current quality of life, we need to challenge the way that we're using, discarding, and manufacturing materials today.
I'm inside a factory in upstate New York where new breeds of renewable construction products aren't made, they're grown. This new process is based on an unconventional source, the root structure of mushrooms known as mycelium.
In about 5 years, we do expect you to be building your home with mushroom materials.
What are the problems with the existing traditional materials that we use for building and other products?
Traditional engineered wood products today, they are made out of wood. Their principal composition, typically somewhere around 85% of the total mass, is wood. But the remainder of that is typically synthetic resins that are first derived from natural gas, which is a finite resource, and second are human carcinogens. They're formaldehyde-based.
When you say engineered wood products, you're talking about things like what people might call particle board.
Exactly. So the materials that make up either the chair that you're sitting on in your office or the desk or table in your home.
By replacing formaldehyde with mycelium, Ecovative can create materials with properties similar to fiberboard without the health and environmental complications.
Even in nature, mycelium is like a natural adhesive. It actually holds the forest floor together. What we do is use two constituents, ground up crop waste or wood waste. We inoculate that with mycelium, and then the mycelium does the work. It actually eats that ground up material, and it grows through and around the particles, binding them together through the growth of the organism, transforming discrete particles into a physical composite. So essentially, we're using nature's technology to grow a glue.
So this is what you're growing here. This is what's in all these racks behind us.
That's correct, yeah. So what we have here is we have an enclosure, and what the enclosure does is it provides the shape or the geometry that we're looking to grow.
Cool.
So let me crack this open.
All right.
So all of the white material that you see here, and you can touch this is really pliable right now because it's still alive.
Oh, it's spongy.
Yep, it's a living, breathing fungus right now. So let's take a look at the side of it here.
Yeah.
Because what you can see is we've got some of the corn stalks and corn waste completely encapsulated with mycelium. So if you try pulling it apart, you can see that's pretty tenacious and tough.
Right. And how long did it take to get from basically raw ingredients to this?
This panel here grows for 4 days.
And what day is this?
This is day 4, so this is ready to go to our press. So what the press is going to do is that it's going to consolidate or squish this material down to a thickness that could be used in the furniture industry. It's removing any of the remaining water, it's killing the fungus, but it's also increasing the stiffness exponentially. So it's increasing it to a range where you would see traditional wood products. This takes about 10 minutes to press and remove all the water and to set the mycelium so it maintains the shape that we're looking for.
And at the end of that 10 minutes, we're left with something like this?
That's right, yeah. So what we have here is a rigid board material.
Yeah.
And this is used as a chair back.
And as far as cost is concerned, how does something like this compare to, say, plywood?
So right now, this is actually being sold at a slightly lower price point than traditional plywood products.
So far, Ecovative has been able to make chairs and packaging materials from its renewable mix of plant waste and mushroom roots. But the company sees this as only the beginning to what you can do with fungus.
Mycelium is a naturally occurring polymer, and we think most of the best applications for this platform are when we're replacing other synthetically derived polymers.
We only have one planet. And if we're going to continue to grow and prosper as a people, it means that we can't be reliant upon materials that can't be upcycled or reused in the future.